Good day everyone, my name is Mohammed Jamil Ahmed and I am a cybersecurity student at Bahrain Polytechnic. I served as the project manager and team leader for our office network simulation project, which was developed using Cisco Packet Tracer. The objective was to design and implement a secure virtual network infrastructure operating using VLANs, routing protocols, and Internet of Things devices integration to emulate a professional office environment. This project presented significant challenges, but our team achieved a successful outcome. Today, I will outline my contributions, responsibilities, and the key lessons I gained from this experience. As a project manager, I was responsible for coordinate the team efforts within the Packet Tracer environment. I assigned tasks strategically, aligned them with individual strengths, delegating VLAN configurations to our network engineer units due to his experience in switch management. I ensured the team followed the project objectives practically during complex phases such as routing protocol implementation. In my role as communication lead, I facilitate regular progress updates and redistribute tasks as needed, such as when troubleshooting efforts require additional support. Additionally, I organized weekly meetings, established agendas, and document action items, assuring follow-through on critical deliverables, such as the user guide drafted by Hassan. My focus was to maintain teamwork and drive the project forward. My contributions spanned multiple facets of the project in Packet Tracer. I began by identifying stakeholders such as hypothetically IT department that would utilize the network to ensure our simulation addressed their requirements. I developed the project schedule detailing tasks such as creating the network topology diagram and validating connectivity to maintain organizational clarity. Collaborating with Hassan, I drafted the project budget, estimating costs for virtual equipment, including Cisco 2960 switches, 2811 routers, and server license within Packet Tracer. I also compiled a comprehensive device list specifying all necessary components such as PCs, switches, and Internet of Things devices like smart sensor. During the testing phases, I helped resolving an issue with IP configuration, which I helped configuring the DHCP server to configure the IP addresses of all the end devices within the network without needing to configure it statically. I led the project closure, reviewing all configurations, capturing screenshots, and documenting lessons learned such as strategies to prevent IP addresses conflicts. My primary responsibility encompassed planning, coordination, and quality assurance of the Packet Tracer network. I formulated the project plan, assigning tasks such as OSPF, routing configuration to Yunus, and documentation to Hassan, and testing for Abdurrahman Shabili. While mentoring progress through a detailed task tracker, as the central point of communication, I relayed updates across the team and intervened when issues arose. I collaborated with the team member to address technical challenges, including misconfigure access list in the system and the network. I conduct a thorough review of all deliverables, including configuration, screenshots, and the user's guide, to ensure they met the project standards for handover. This project provided critical insights for my professional development. First, task distribution impact efficiency. Second, planning is crucial for avoiding delays. Third, importance of clear communication among team members. Last but not least, planning is crucial for avoiding delays. In conclusion, our team successfully delivered a robust network simulation in Packet Tracer. The network features fully configured devices, properly segmented VLANs, and operational routing protocols such as OSPF, ensuring seamless data flow. Extensive testing, including pings and simulated traffic analysis, confirmed reliable inter-VLANs and Ethernet connectivity. Our documentation, including our configuration screenshot and user guide, was completed to a high standard. The team effective collaboration was the main key to this success, and I am proud of my leadership in guiding us to achieve this outcome. Thank you for your attention, and I hope this presentation was good.
Hello everyone, my name is Hussein Fadl Nasser. I'm the network architect for the Office Network Simulation project. Today I will walk you through my contributions to designing a secure, scalable Office network using Cisco Packet Tracer. This presentation will cover my role, key responsibilities, timeline, and lessons learned, all within the next 5 to 6 minutes. Let's start with my role as the network architect. I was responsible for designing and validating the network topology. This included VLAN segmentation, inter-VLAN routing, and integrating Internet of Things devices securely. I also helped to configure layer 3 switches and routers, enforce security policies through access control lists, and created detailed technical documentation such as IP schemas and configuration scripts. My goal was to ensure the network was efficient, secure, and ready for future physical deployment. One of my key contributions was the VLAN strategy. I segmented the network into dedicated VLANs for departments. This segmentation reduced broadcast congestion and isolated traffic, enhancing both performance and security. For example, the breakroom VLAN was restricted to prevent access to sensitive departmental networks. Next, I configured inter-VLAN routing on a multi-layer switch by setting up switch virtual interfaces for each department, assigning gateway IPs and DHCP pools to enable dynamic addressing. This ensured seamless connectivity within and between VLANs. Next, I prioritized security by designing the breakroom ACL. This blocked the breakroom VLAN from accessing sensitive VLANs like IT and finance, while still permitting essential services such as DNS and DHCP. Cross VLAN traffic was restricted to authorized communication only. Finally, after testing with the QA tester, I enforced bandwidth limits to optimize the network performance. This balanced resources allocation across departments, maintaining efficiency without compromising security. My responsibilities also included documentation. I produced network topology diagrams, VLAN and IP plans, configuration reports, and all shared with the team for alignment. These documents ensure the simulation can guide a real-world deployment. Let's look at the timeline. From March 15 to 23, I drafted the VLAN and IP addressing plans. Between March 24 and April 8, I was consulted for the configuration of the multi-layer switch and routers, which created a functional simulation file. From April 9 to 16, I validated ACLs for the production of a security report. Finally, by April 22, I completed the network with no delays. Collaboration was key. I worked closely with the network engineer to configure devices and shared scripts for consistency. I also partnered with the QA tester to validate traffic isolation, refining ACLs when overly restrictive rules blocked legitimate traffic. Feedback from testing helped perfect the security policies. One challenge was the breakroom ACL blocking DNS. Employees couldn't browse the web. We brainstormed fixes. Removing the ACL was risky. Allowing all DNS was insecure. Instead, we refined the ACL to permit only internal DNS. After testing, connectivity worked and security stayed intact. Simple adjustments saved the project. Monitoring progress was critical. I tracked milestones like completing VLANs, segmentation by March 30, and validating routing by April 5 when issues arose, such as ACL misconfiguration. I adjusted rules promptly to maintain alignment with the project goals. We achieved significant successes. The network fully isolated VLANs while enabling secure inter-VLAN communication. The Internet of Things VLAN operated without leaks, and the simulation validated our design scalability. However, I learned that tools like Cisco Packet Tracer have limitations such as incomplete ACL logging, which could affect real-world planning. Clear documentation also proved essential for deployment readiness. In conclusion, my work as network architect delivered a robust, secure network simulation that addresses operational inefficiencies and sets a foundation for future deployment. I'm proud of our team's collaboration and innovative integration of Internet of Things that enhances both security and efficiency.
Good morning, everyone. I am Yunus Fahid, a network engineer from Bahrain Polytechnic, and I'm excited to present our Office Network Simulation project. This project, built using Cisco Packet Tracer tool, showcases a secure and scalable Office network with VLANs, IoT integration, and security measures. My role as the network engineer was critical in bringing this design to live. And now I will walk you through my contribution, the process, and our achievements. Let's start with my role. As the network engineer, I was responsible for configuring end devices, PCs, servers, and IoT devices, and also assigning them to their respective VLANs such as IT on VLAN 10, HR on VLAN 20, and IoT on VLAN 60. I set up VLANs on each room's switch, ensuring proper trunking to the multi-layer switch for seamless connectivity. I also isolated IoT devices on VLAN 60 and breakroom devices on VLAN 70, both with secure wireless access using SSIDs, IoT, and breakroom. A key part of my work was implementing inter-VLAN routing on the multi-layer switch and configuring access lists like the breakroom filter to enhance security by blocking unauthorized access from VLAN 70 to other networks. My contributions spanned the project's key phases. During planning, I collaborated with the network architect to ensure VLAN assignments aligned with room needs. In execution phase, I set up PCs, servers, and IoT devices, assigned IP addresses, and configured switches from VLAN 10 to 80. For testing, I performed ping tests to confirm inter-VLAN routing worked as expected. And also I have worked with the QA tester to validate the breakroom filter access list, ensuring it effectively restricted traffic while allowing essential services like DNS and DHCP. My main responsibilities included four key areas. First, I planned the routing strategy to ensure optimal connectivity across VLANs. Second, I configured the multi-layer switch, enabling inter-VLAN routing and setting up DHCP pools for dynamic IP allocation across all VLANs, with exclusions to avoid conflicts. Third, I delivered configurations to testers and resolved post-validation issues such as IP overlaps. Finally, I implemented security by creating the breakroom filter access list, which blocked VLAN 70 from accessing internal VLANs while permitting necessary traffic, ensuring both security and functionality. Collaboration was key to our success. I worked closely with the network architect to align VLANs setups and with the QA tester to troubleshoot connectivity issues. I also refined access list rules based on the testing feedback to meet security policies. To ensure team alignment, we shared setup scripts like device configuration, which I prepared for consistency across VLANs. I faced a challenge with DHCP misconfigurations, causing IP conflicts in VLANs 10 and 20, impacting IT and HR connectivity. After brainstorming, I reassigned DHCP pools, checked for overlapping excluded addresses, and reserved IPs for static devices. I then updated the DHCP excluded addresses on the multi-layer switch, retested connectivity across all VLANs, and confirmed stable IP assignment, resolving the issue effectively. In the end, we successfully configured all devices and VLANs with zero IP conflicts, and the IoT and breakroom VLANs were fully functional. A key lesson learned was that simulation tools like Packet Tracer require accurate configurations, especially for DHCP pools, to avoid issues in later stages. This project teach me the importance of planning and collaboration in network designing and implementation. Thank you all for your attention. I'm happy to answer any question about my role or the project.
Good morning, everyone. My name is Abdurrahman Salim Ali, a quality assurance tester in cybersecurity program at Bahrain Polytechnic University. I'm thrilled to share my roles in the Office Network Simulation project, where I helped ensure a reliable and secure network. I had four roles: test analyst, test executor, defect reporter, and documentation specialist. I checked what network needed, made test plans, ran tests, fixed problems, and kept clear records. I also test inter-VLAN connectivity to make sure every device in the networks can talk to each other easily. And I checked routing functionality to keep data moving correctly. My participation really came to life in a few key areas. In the planning, I joined team meetings to align our testing strategies with project's goals and timelines. It was great to brainstorm together. For cutover execution support, I helped make sure the network went live smoothly with all features working as expected. In testing and troubleshooting, I ran in-depth network tests, pinpointed connectivity issues, and validate fixes to boost performance. And for documentation, I kept accurate records of test cases, configurations, defects, and resolutions, which helped with compliance and sharing knowledge with the team. My main responsibilities were testing network parts, checking routing, and reporting problems. I tested switches and routers to ensure connection and VLAN worked properly. I checked the network's speed and strength to keep it strong. I also confirmed that routing settings sent data to the right places, which was vital for our office users. I found a lot of problems, so I worked with the network architect and the network engineer to fix these problems. After that, I wrote down details about those issues to help them later. These steps ensured the network was high quality and reliable for everyone. A significant deliverable was network testing report. The report comprised 4 key sections. The purpose section outlined the objective of validating network functionality and identifying defects. The findings section detailed issues such as IP configuration errors, bandwidth allocation imbalance, and access control list misconfigurations, which impacted performance. The conclusion summarized the test outcomes and their implications. The expected benefits section highlighted the improvements, including enhanced network throughput and security. This report guided the team in optimizing the network for end users. This project taught me valuable lessons. Collaboration drives success, as working closely with the team ensured we met project goals efficiently. Clear communication is fundamental, enabling us to align on testing strategies and resolve issues quickly. I also learned more about Packet Tracer features, which improved my ability to simulate and analyze network configurations effectively. These lessons improved my technical and teamwork skills.
Hello, my name is Hassan Jamal Ma'inin, and I'm currently taking the Applied Projects course. I'm also a second-year student at Polytechnic Bahrain. For this project, I took on the role of technical writer, where I was responsible for producing, organizing, and finalizing all major project documentation that supported both the technical execution and the end user experience. My role involved more than just creating documents. I led some of the core documentation process throughout the project. I applied my strengths in structured writing and worked closely with the network engineer, project manager, and architect to ensure all content was accurate, aligned with the implementation, and accessible to its intended audience. I took full ownership of each document, from initial drafts to the final version. These are my main role and responsibilities. As the technical writer, my responsibility was to take technical input from the team and convert it into organized, understandable, and polished documentation. Here's a quick summary of the key documents I handled. For the project charter, I created this early in the project to define our goal, the scope of work, and the constraints we'd be working within. It also outlined potential risks and listed the assumptions that guided our planning. It also gave our team a reference point throughout the project whenever priorities shifted or scope questions came up. For the risk log, it included the most critical risks we could face. For example, VLAN misconfigs or even hardware failure, along with practical mitigation strategies to help us stay ahead of problems. This helped us stay proactive by planning for the unexpected, which saved us time during the implementation phase. For the project diary, I maintained this to track task ownership, due dates, and also major milestones. It ensured we had a complete record of the project's lifecycle, not only for the beginning of the project, but from start to finish. It also helped during reflection and project closure, showing exactly how and when key milestones were achieved. The configuration report was a document that is technical in nature. It listed all of our configurations, VLANs, IPs, trunk and access port settings, DHCP pools, ACL rules, and rate limiting. It's designed for future maintenance and troubleshooting by other admins. I included visuals and simplified instructions, ensuring that even users unfamiliar with the networking could follow along confidently. For the key learning outcomes, this role taught me just how important clear and consistent documentation is in real-world IT projects. It supports team coordination, reduces confusion, and becomes a vital tool for future reference. I developed stronger technical writing skills and improved my ability to collaborate with both technical and non-technical team members. I also deepened my understanding of networking concepts such as VLAN segmentation, DHCP configuration, and ACL design. Not by setting them up directly, but by studying and documenting them in detail. Overall, I learned how to take technical complexity and turn it into something usable, readable, and valuable for everyone involved.